Right, so recording stopped there, but now it's continuing. So here, when x is equal, we found that, and then for your y-intercept, you let x equal to 0, y is equal to 6, let x equal to 0, I got 18, and then I got 3y, simple divide by 3, so you get 6. Right, so that's my y-intercept for this one, and for that one. Now, what about turning points? Okay, so for turning points, you can use minus b over 2a, but let's use first derivative here since we are dealing with calculus. So for your turning points, you make dy over dx equal to 0. Right, so your dy over dx, let's find dy over dx. So the derivative here, that's a 0. This is a 1, and this is minus 2x. The derivative of minus x squared is minus 2x. So now at the turning point, the first derivative is equal to 0. So 1 minus 2x equals to 0. And now we can solve for x. So now 1 is equal to 2x. So therefore 1 over 2 is equal to x. So the x value of the turning point is 1 over 2. Now we need to find the corresponding y value. So I will take x, substitute into that original equation. So y is equal to 6 plus x then minus x squared. So my x here is 1 over 2. 1 over 2. What do we get? We got it already. So that's 6 plus half minus 1 over 4. So that's going to be 24 over 4 plus 2 over 4 minus 1 over 4. So that's 26 minus 25 over 4. Is that correct? 25 over 4, 6, 5, 4 can go into 25, 6 times. So that's 6 comma 25. Is that correct? Yes. Right, so that is the y value of the turning point there. Here, if I substitute here, let's see what will happen now. Okay, I need to find the first derivative. So we know that turning point dy over dx equals to 0. So now, here, here I have to divide by 3 first. Okay, so that's going to be y is equal to 2 over 3 x squared minus 12 divided by 3 is 4. 18 divided by 3, that will be 16. So that is my y. So now dy over dx, the derivative here is going to be 2 over 3 times 2, that will be 4 over 3x. The derivative of minus 4x will be minus 4, and the derivative of the constant is 0. Okay. Or you didn't, if you did not want to, you didn't have to divide by 3. You could have just differentiated it one time. On the left-hand side, the derivative of 3y is going to be 3 times dy over dx. Remember implicit differentiation. So you did not have to divide. I'm talking about you didn't have to divide it. So what do we know? At the turning point, dy over dx is equal to 0. So 4 over 3x minus 4 is equal to 0. Solve for x here. So that's going to be 4 over 3x is equal to 4 if I take 4 to the right. So therefore, x is going to be equal to 4 times 3 over 4. So what am I doing? I'm going to multiply by 3 over 4 on both sides because I want to cancel 4 over 3. So I multiply by 3 over 4. 3 and 4 and 4 over 3 and 3 over 4 will cancel. And what do I end up with? Just 3. So x is equal to 3 here. I don't have space, but you can work that out. So when x is equal to 3, what do we get? 3y is equal to when x is equal to 3, when if I substitute onto the right hand side, what do I get? What do we get here? So I got 3 squared is 9. Oh, we did it here, isn't it? Let me just see. Yes, so there's it here. So we're going to get 0, correct? When we did it here, remember that. When x is equal to 3, y is equal to 0. So then 3y is equal to 0, y is equal to 0. So I got my turning point there, which is 3, 0. Here, my turning point is 1 over 2 and 6, 25. Alright, so now I'm going to erase the board and then let's put all this information onto the graph. So you didn't take it down, you take it down. Right, so let's sketch these graphs. So now, let's draw our xy axis. Right, so for this graph, what did we have? Our x-intercepts were 3 and negative 2, y-intercept 0, 6, turning point 0.5, 6.25. So let me just go. Right, so I'll call this 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. Let's see. When you're plotting your parabola or cubic graph, the best thing is to label the turning points first. Right, so my turning point for this one is 0.5 and 6.25. So let me just did you all try and sketch it? So that is 0.5. So if this is 0 and this is 1, 0.5 is somewhere around here. So there's my 0.5. And the y value of the turning point is 6.25. So if this is 1, 2, 3, 4, 5, 6. 6.25 is somewhere here. So that's 0.5, 6.25. So that is the turning point. And I'm talking about this graph. And the shape here, you know it's going to be concave down or a sad face because this is in negative here. Can you see that? So you know this is the turning point here. It's going to turn like that. That is your turning point. You can see that. So it's always turning point first, y-intercept second. What is the y-intercept of this graph here? So the y-intercept is 6. So you can see that you're going up 6.25 and then you have to pass down through the 6 there. And then you're coming down. What are the x-intercepts here? Minus 2 and 3. So you're coming down there. So that will be our minus 2. There's my minus 2 there. And the other x-intercept is 3. So that's 1, 2, 3. So you're coming down here. Alright, so that is our parabola. So this was a minus 2, 0. This is a 3, 0. This turning point is 0.5, 6.25. This y-intercept here is a 0, 6. There's nothing more we need to write down here for this parabola. Now, the next parabola. Right, so what do we have here? The shape here, even if you divide by 3, it's still going to be positive here. The coefficient of x squared is positive even if you divide by 3. So it doesn't matter, it's positive. So you know it's concave up, happy face. What is the turning point for this one? Right, it's always turning point first when you're sketching the graph. Turning point 3, 0. So that means it turns at this point here. 3, 0. Alright, so there's your 3, 0 here. This is the turning point. So now let's see, it's going to go up there. Turning point, y-intercept. What is the y-intercept of this graph? That's the next thing. It is 6, so it needs to go all the way up there. So you're going to go there. There's your 6 there, you can see that. And then up here, although it's unnecessary, but we have to sketch. Those are the two graphs. Right, now, let's label. Is there anything that we left out here? Well, the 3 and 0 is already here. You can see that. Here's your 0, 6. So there's nothing else for me to do here except label the graphs. So what is this graph called? This here is 3y is equal to 2x squared minus 12x plus 18. And this graph is y is equal to minus x squared plus x plus 6. Very important that you see the picture here. Okay, now let's see our area. Can you see the calculated area? Draw your representative rectangle. Let me give you a chance to draw the representative rectangle. Right, so now we need to make a choice. Okay, so we have an area. So there is your area. Let me just redraw this area to show you exactly what's happening here. So we have this part here, and we have this part here also. That is the area that you can see. Right. That is the enclosed area between the two parabolas. That's what it states. Right, that's the only enclosed area we can see. Right, now, what are we going to do? Are we going to choose a rectangle with a breadth of delta x or a rectangle with a breadth of delta y? That's the question. Now, the volume question in N5 will give you a hint on what's going to be happening on which one to choose, basically. Right, because in N5, there's only one method you use for volume. It's called the disk method, which is the second question, yeah? The first one is calculating area. So, the hint here is go to the volume question, calculate, and then check which axis are we rotating about. Rotating about the x-axis, that means you do not have any choice. You have to use delta x when it comes to the volume question. So why not use the same thing for area? Okay, so use the same thing for area. So, because you do not have a choice, you stick to only one technique here. So we're going to use delta x. Now, that is just a hint now in case you get confused. But for your understanding, why is it better to use delta x rather than delta y? That is the question. Why is this a better option? So let's draw our delta x here. So if I draw my rectangle here, let's draw another one here. You can draw it anywhere you feel like. Draw and always check what's touching the top end, what's touching the bottom end here. The top end point of that rectangle is the red graph here. Can you see that? The parabola. It's this one. Okay. And the bottom is always the black graph on the board. Can you see that? Now, this is top, that's bottom. Top, bottom, top, bottom. So the top is always this parabola, the bottom is always that. But what happens if you decided to do it the other way? So if I'm going there now. Now, if I use delta y, let's see, there's my delta y. If I draw it here, that's fine. So what's touching on this side is this graph. What's touching on that side is the other graph. Can you see that? But now, the question is it true everywhere? Okay, the answer is no. It's not true everywhere. So if I do it here, we got a problem now. What's touching is only the parabola on both sides. When I say we got a problem, I don't mean it's a problem to work it out. The problem is it will take too long to work it out in the exam because we have to split up now. We have to split up. There's a small area here and there's a larger area here. That means you must calculate this area plus that area and work it out. There's no time for that in the exam. So you choose the better option where it's only one area. Right, and you will see when you come to N6 how important it is to make a correct decision. A decision that will enable you to work it out easier than the other option. So right, so now we are going with this option here. Right, so that is our representative rectangle. So this is the one 4 that we're going to be using. Now let's answer the area question. So calculate the magnitude of the area. Right, so calculate the magnitude of the area. So what do we know? We know that area, delta A, area is equal to length times breadth of a representative rectangle. So I'm going to go length times breadth. Right, so let's check now. What's the length and what's the breadth? Right, so now we check the top and the bottom. So you go to your diagram. So this is the top, you can see that, and this part here is the bottom. Right. So the top is this graph here. So what is this graph? What did we label this graph as? Yes, let's call this one y1. So the top I will call it y1. You can see I just decided to call it now y1. Doesn't matter whether you call it y1 or y2, but what matters is you understand that this is the top. So I'm calling this y, the point here is y1, and what's touching the bottom is a different graph. Let's call this one y2. So if I want to work out the length is the longer side. That means I must take the top y value minus the bottom y value. You can see that. So now your length is going to be top minus bottom, y1 minus y2, or if you call the top y2, then it's y2 minus y1. Right, but the main thing is the red graph is the top graph. That's the main thing that you need to see. Right, so y1 minus y2, that's your length, times your breadth, which is delta x. So there's your breadth here. The breadth is the change in x, delta x. The length is the change in y. You can see that. Now, total area. Now I'm not writing down delta A. This is the formula for the small rectangle, the representative rectangle. You must write this down first. Then you write down the total area formula. You put in your integration. It gives you the sum of all the area. So that's A, B, y1 minus y2 delta x now becomes dx. We are integrating with respect to x. Now A and B. Oh, I just realized what did I forget to put points of intersection, but it's already here now. Okay, points of intersection. What were the points of intersection? 0, 6, 3, 0. The points of intersection after working out the x and the y intercepts, it happened to be here. You can see it. Now, what values do we use? To integrate, it is the points of intersection according to this sketch here on the board. So, this A and B, what are those values there, A and B? So now remember, dx means you are integrating with respect to x. So, look at the area, the x value on the left and the x value on the right. Okay, the beginning is on the left, the end is on the right. So, the beginning, there's the area here. You can see this is the entire area here. So, this is where it begins. It begins at x is equal to 0. And you go to the right, extreme right, it ends here, and it ends at x is equal to 3. So, now the lower limit in the bottom, upper limit on the top. So, let's write that down. So, my area is equal to, that will be 0. 3, y1 minus y2. So what is y1? Y1 is minus x squared plus x plus 6. That's my y1 minus y2. What is y2? I didn't even see what's y2, but I'm opening up a bracket. Why? Because every time you put a negative, you must open up a bracket. Now, what is y2? Here's y2. But sorry, this is 3 times y2. Obviously, I need to divide by 3 first because I need to make y2 the subject of the formula. So y2 is, we just did it a few minutes ago, so that's 2 over 3 x squared minus 4x plus 6. And now it's just all about simplifying here. There's nothing, we definitely do not need any formula sheet to integrate this. But let's simplify it first. So that's going to be minus x squared plus x plus 6. It'll be minus 2 over 3. X squared minus times a minus is a plus. 4x, a negative times a positive is negative. 6. You can integrate, or I'm just going to simplify further to make it simple in the board. So I got minus 3 over 3 minus 2 over 3 is minus 5 over 3. X squared, what else do I have over here? I have an x plus 4x, which is 5x. And what else do I have? Constant, positive 6, negative 6, that's 0. Right, so I simplified. You do not have to simplify. You can leave it as it is here, integrate it and substitute. Right, so now let's integrate. We're going to be substituting our 0 and 3. So I'm integrating minus 5 over 3, so that's going to be minus 5 over 3. When I integrate the x squared, it's going to be x to the power 3 over 3. Are you clear with that? Yeah, I got my plus 5. When I integrate x, it's going to be 1 plus 1, which is 2 over 2. So this becomes minus 5 over my 3 times 3 there, which is 9. X cubed plus 5 over 2 x squared, that's my 3, 0. You got an answer for me then? Let's check. Minus 5 over 9. What you get? 15 over 2. So we get 15 over 2 units to the power 2, because this is area. When you substitute 0, you're going to get 0 here. You can see that. So this was the area, which was not too bad. The next one will take a little long. So you copy this down. I need to erase the board. And the volume one is going to take a bit long to work out. Right, so let me just set up what's going to happen here. Right, so the last question is calculate the volume when this area revolves or rotates around the x-axis. Right, so now let's write this down. That's 5.2.4. So the question is, it rotates about the x-axis. Right, so now this area rotates about the x-axis. Now, we'll go to a new check now. I'm just going to explain to you why we are using this method. So now here's your representative rectangle. If you extend it all the way down from here to the x-axis, and here's your x-axis, and here's the representative rectangle. So here it is perpendicular to the x-axis. If you erase this part and you draw it all the way down here, your rectangle, it's going to be intersecting the x-axis at 90 degrees, so it is perpendicular to the x-axis. Right, so now, let me just do a quick summary here. So we know this representative rectangle is perpendicular to the reference axis. Perpendicular, and that is the reason why we use the disk method. So therefore, we will be using the disk method. There's another method you're going to learn, but not now, next semester in N6. That's called the shell method. Then you have to know exactly which one to use, this or shell. In fact, you'll have a choice. You can use any method you want to. Now, so when it is perpendicular, we use the disk method. What is the disk method? Right, so the disk method, volume is equal to area of base times the perpendicular height. That is the disk method. Area of base times perpendicular height. The shell method is something different. Okay. So, what is the area of the base? What is the height? So now, what's happening here is this is going to be rotated. So we're taking this here and we are rotating it around the x-axis. Okay. So your axis of rotation is the x-axis. So what's happening here is you're going around there. So we need to determine our radius. What is our radius measured in terms of? Now what do I mean? Why am I saying that? Because volume is equal to pi r squared h. This is the formula that we're using. Okay, pi r squared. Area of the base is a circle. Area of a circle is pi r squared times the height, which is h. Now what you need to do is you need to determine this r and h there. Okay, so h will be the thickness here. This will be the height, the delta x here. So when you are using the disk method, right? If you have delta y, that will be the height. If you have delta x, that will be the height. You can always check other examples that I've done more in detail on explaining this here. So, but h is equal to delta x. What is your radius measured in terms of? So if you're going up and down, that means you're going up, you're measuring a y value, and you're coming down. You are not going left and right. If you're going around the y-axis, then you are going left, and then you are going right, so you're measuring in terms of x. In this case, I'm rotating about the x-axis, so I'm going around, so my radius is in terms of y. Your radius is in terms of y. Right, so you make sure this is correct, otherwise everything goes wrong here. Now, the fact is, how many graphs are we dealing with? We are dealing with an enclosed area, top graph, bottom graph. So what did we do here? We went area of the top graph minus area of the bottom graph. So that's what we're going to be doing here. So I'm going to go delta Vx. That means rotating about the x-axis. I'm going to go volume of the top graph minus volume of the bottom graph. That is how we deal with the disk method. It's volume of the top graph minus volume of the bottom graph. So, if we're talking, I'm just going to go in detail, then I'll show you a shortcut here quickly, what to remember, right? But this is a proper way. Volume of the top graph minus volume of the bottom graph. Which is the top graph? The top graph is y1, the bottom graph is y2. So now, volume of the top graph is going to be pi r squared, so that's going to be y1 squared times delta times h, which is delta x minus volume of the bottom graph. The bottom graph here is y2. So that's going to be pi y2 squared times, it's the same, delta x. What happens now is we factorize this so it looks neater. So you take out pi as a common factor, take out also delta x as a common. It's just that we write pi here, delta x there, it's multiplication, it doesn't matter. So here we get y1 squared minus y2 squared. Now, if you thought that was too difficult to remember, then this is the trick here. You watch this. Can you look at the area formula? Here's it. y1 minus y2 delta x. Look at the volume formula. All you need to remember is put a pi in front, square there, and that's a volume formula. Can you see that? But obviously this must be correct. If this is correct, volume will also be correct. Alright, but that's just a shortcut way of, remembering how to write it if it's two graphs. Now comes the long part. So let's write down our total volume formula. So now I'm going to go pi, same b and a, y1 squared minus y2 squared. There's my delta x there. So what am I going to do now? I got my pi. What is my b? It's the same b and a here, you can see there, which is 3 and 0. And then I got y1 squared minus y2 squared. What is y1? We already have y1 there, we have y2. We're just transferring the same information here, but this time we're going to be squaring it. So what is y1? Here's your y1 here, which we already worked out. So this is y1 minus, this is your y2. I'm just transferring them. So my y1 here is minus x squared plus x plus 6. y2 is 2 over 3 x squared minus 4x plus 6. And this is the part now where it takes long to square. And this is the difficult part of this problem, I would say, is to make sure we need to square this. We need to square that. You need space on your page here. We need to square this whole thing out. Let me give you 2 minutes to try because it's going to take long. We have to square it. There's 3 terms to square. That's why it takes long. Let me give you a chance to square it. Alright, so we need to work out the volume. Before we even start, I'm just checking my final answer using, I just showed it now. We can obviously work out our final answer if we have this advanced calculator. So we know we're going to be doing a lot of work on the board now. But let's check our final answer is 99 over 2 pi units to the power 3. If I just work this out, it becomes 155,508,8364. You got that? Well, I didn't work it out yet. Units to the power 3. So this is our final answer without working out anything yet. I just checked it. Now let's see what's going to happen. Alright, so the whole thing here is to square this here. That is the problem here, is to square it and try and not make a mistake. So what we have, let's do the squaring here. So I got minus x squared plus x plus 6 all squared. Okay. Which is the same as minus x squared plus x plus 6 times minus x squared plus x plus 6. That is what we have. Right. So it's going to take long. You're going to multiply this whole thing out. So you're going to go that time, that, how many times? Right. You can try and fast track this here. This fast track, that means try and work it out faster if we go a plus b all squared, which is a squared plus 2ab plus b squared. But now, we don't just have a plus b there. Can you see that? There's three terms there. So if you want to, you can say a is minus x squared and b is x plus 6. If I want to, let's see. Alright, so if I go a squared, I'm going to go minus x squared all squared plus 2 times a times b, 2 times minus x squared times x plus 6, so that's plus 2ab, and then plus x plus 6 all squared. It might take long, it depends on if you can do this quickly. Alright, so let me square this. So minus x squared all squared will be a positive x to the power 4. So I got minus 2x squared times x there, which will be minus 2x to the power 3. Minus 2x squared times 6 is minus 12x squared. So that part is done here. I got x squared. I'm using the formula again now. So this is a plus b all squared. So that's going to be x squared plus 6x times 2 is plus 12x plus 6 squared is 36, and I'm done with this one now. Alright, what can I do? Simplify. That's going to be x to the power 4 minus 2x cubed. Minus 12 plus 1 is going to be minus 11x squared. And then I got plus 12x plus 36 there. You'll get the same thing. Alright, so I'm just using the formula here. Let me do the other one now. What do I have here? I have 2 over 3 x squared minus 4x plus 6, and I want to square this whole thing. So in this case, I'm going to say let my a be 2 over 3x squared, and my b will be minus 4x plus 6. So I'm going to try and do it fast. So I'm going to go a squared, so that's going to be 2 over 3x squared all squared plus 2ab, so that's going to be plus 2 times a, which is 2 over 3x squared. My b, I'm treating it as minus 4x plus 6. So I'm using the formula a squared plus 2ab, and then I'm going to go plus b squared. Right, let's see what happens. So I got 2 over 3x squared all squared, so that's going to be 4 over 9x to the power 4. Alright, here, this is going to be 2 times 2, which is 4 over 3 times minus 4. That's going to be minus 16 over 3x to the power 3. Then I'm going to go 4 over 3x squared times 6. That's going to be 24 over 3 x squared, which is actually 8. What about this one? That's going to be plus minus 4x all squared. That's going to be 16x squared. Middle term, minus 4x times 6 is minus 24, times 2 is minus 48. So that's going to be minus 48x. And then 6 squared is 36. Alright. So what do I have now? That's going to be 4 over 9x to the power 4. Then I got minus 16 over 3x cubed. And then 24 divided by 3, that is 8. Plus 16, that is 24. And what else? That's all. Minus 48x plus 36. Alright. Now, that is just squaring out. Now, what was the question here? To subtract it. That squared minus that squared. Do you want to simplify? It's your choice if you want to simplify. So what am I doing now? I'm going to take this. And we take this here. Right. So I'm going to take that, subtract this here, because that's what it is. You can see that, subtract that, and now we can do it here. So your Vx is equal to pi 3, 0. So what am I going to be subtracting now? I'm going to take that minus that. You're clear? I'm not going to go and write it all. It takes too much of space here to write that out. So I'm going that, subtract the bottom. So that's going to be 9 over 9 minus 4 over 9, which is going to be 5 over 9 x to the power 4. Clear with that? Right, so that's 9 over 9 minus 4 over 9, which is 5 over 9, minus 2 minus 16 over 3. So basically I've got minus 2 plus 16 over 3, so that becomes minus 6 plus 16, so that's going to be plus 10 over 3. X cubed. What else am I subtracting now? I'm going to go minus 12 minus the 24, x squared. So minus 12 minus 24 is going to be minus 36x squared. What else do we have there? No, I'm wrong. Sorry, I'm wrong. I was looking at minus 12. Sorry. I'm looking at actually minus 11. Minus 11 minus 24 is going to be minus 35. Okay. And then we have our other term there. I've got 12x minus 48. So 12 plus 48, that's going to be 60. So that's plus 60x. And then I've got 36x minus 36, which is going to equal to 0. Right. So now we integrate. Let me just see, some students want to come in there if we get the same answer. Right, so let's assume now, I hope this is correct. If we've checked it, so let's integrate. So that's going to be 5 over 9 x to the power 5 over 5 plus 10 over 3 x to the power 4 over 4 minus 35 x to the power 3 over 3 plus 60x squared over 2, substituting 3 and 0. Alright, let's check this here quickly now. Alright, so now when I substitute 3, I get 99 over 2. Minus, when I substitute 0, I get 0. Obviously, you can see a 0 here. Oh, and that is a relief. So we're lucky there is no mistakes. Right, so 99 over 2 times pi is 99 over 2 pi, which is equal to 155.509 units to the power 3, and that is correct. We verified it on the advanced calculator. Alright, so